told you that one of the most powerful tools for solving global water scarcity looks exactly like a piece of ice. This unusual crystal traps gas inside tiny cages made of water molecules, and when it melts, it can produce clean, drinkable fresh water. Today, we're going to deep dive into how gas hydrates work and why they might become a key technology for surviving extreme climates. Even though our planet is filled with water, only about 3% of that is fresh water, and 2/3 of that is locked away in glaciers and ice. That leaves less than 1% available for human use. As a result, around 1.1 billion people lack clean drinking water, and about 2.7 billion face water scarcity. This isn't just an inconvenience, it's a crisis affecting health, education, and daily life. Each year, roughly 2 million people, mostly children, die from waterborne diseases, and in many regions, women and girls miss out on education because they spend hours collecting water. Climate change makes this even worse. Rising temperatures dry out soil, shrink rivers, melt glaciers, and increase evaporation, hitting the most vulnerable regions the hardest. So, if the ocean's right there, why don't we just turn seawater into drinking water? The answer is we do. Desalination methods like reverse osmosis and multi-stage desalination makes this possible, but they come with major problems. They use huge amounts of energy, require costly maintenance, and produce brine, a super salty waste that harms marine ecosystems. Desalination helps, but it isn't sustainable enough, especially in regions with extreme heat or limited energy. This is where things get exciting. A new method called gas-hydrate desalination uses ice-like structures made of water molecules and traps gases like carbon dioxide or methane. These structures form in extremely cold, high-pressure environments, such as deep oceans or polar regions, but it can be recreated by scientists. The key idea is simple. When gas hydrates form from seawater, the salt is left behind, and it can't fit into the crystal structure, similar to a coffee filter. Then, when the hydrate melts, it releases fresh water. The process works especially well with liquefied natural gas, LNG, which is already stored at low temperatures, around -162 Celsius. By using LNG's existing cold energy, the system avoids the massive energy costs of cooling seawater. And the result is a huge energy saver. Traditional desalination uses about 65 kilowatt hours per cubic meter, while gas hydrate desalination uses 0.6 kilowatt hours at 99% reduction. For communities facing extreme heat, worsening droughts, and shrinking water supplies, this could be a game changer. Gas hydrate desalination doesn't just make fresh water. It does it using far less energy, fewer environmental impacts, and even turns waste into useful materials. By rethinking how we use cold, pressure, and existing resources like LNG, this technology shows that solving global water crisis isn't just possible, it's already within reach.